Okay, next up, Fuzz Everything, our battle cry. Actually, this is a double-barrel talk. We have Abhishek, Principal Software Engineer from Google, and Fabian, a Senior Software Engineer at Code Intelligence, who'll be telling us a bit about how we can fuzz everything. So the mic is yours.
Abhishek, I think you're still muted. Do you want to go first?
Cool. So let's get started. So this talk is about fuzzing everything in open source with OSSFuzz. And also we will be talking about our recent collaboration with Code Intelligence on Java fuzzing. So first, a little bit background about us. So I'm Abhishek. I work at Google, and we started the OSSFuzz project like 4 years back. And that was in response to the Heartbleed vulnerability. If you remember Heartbleed, that impacted like OpenSSL servers all across the globe and was really an eye-opener for the security community. And now I manage our new Google open source security team. We have like a pretty broad mission to improve open source security at scale. So if you want to learn more, there is a recent blog post on Google security blog called the KPF framework. So definitely check it out. And we have Fabian with us. Fabian, you want to introduce yourself?
Hey, yeah, I'm Fabian. I'm a software engineer at Code Intelligence. I myself in my free time maintain a few security-related OSS projects and also contribute to the Chromium project.
Cool. So first, let's talk about OSSFuzz. For folks that don't know about it, it's a free fuzzing service for the open source community. And we had three major goals when we started this service. The first goal was actually to find all the security vulnerabilities and your stability or functional bugs at scale. So, and also using like really modern fuzzing techniques. So to give you an example, like the latest and very efficient fuzzing engines like AFL++, libfuzzer, hongfuzz are all supported in this service. The second goal we had was to make this platform really simple to use for open source developers. And we really encourage them to do these integrations with the service. So not the security team members, but actual project developers. And we also reward those integrations. And the third goal we had was not just finding security bugs, but also to get them fixed. So if you want to look at some of the OSSFuzz numbers, we have a pretty high fix rate of 90%. And that's all possible because of the smooth workflow we created that even works for the most resource-constrained developers. So a little bit on the history of OSSFuzz. I already told you we started it 4 years back. We started out pretty small, like we had support for only C++ projects. And we started with a bunch of sample projects like OpenSSL, libxml2, etc. Then after 6 months, to increase adoption of the service, we encouraged the open source developers to do these integrations, and we would reward them like up to $20,000 to make those things easier. Then in early 2019, many of these developers were asking us about the backend infrastructure that powers OSSFuzz, so we open sourced that as well. That's ClusterFuzz. They really helped us with good feature requests, gave us some good PRs to add new features. Then later in 2019, we started expanding the scope of OSSFuzz to incorporate new languages like Golang and Rustlang support were added there. Then in early 2020, like in March, we really realized that many of the fuzzing research papers that were coming out every year, we were not able to evaluate them in industry use. And that's where we started FuzzBench as a service, which allowed the community fuzzing research to be evaluated at scale. So you can run, let's say, like 5,000 core experiments and get your results back in 24 hours. So I think this proved out to be useful. Like if you think of AFL++, that kind of graduated out of regular experimentation from FuzzBench. So we feel like we served a purpose there. And then finally, recently we started collaborating with Code Intelligence folks on adding Java fuzzing support. So Fabian will go next on it. So let's talk about like usual fuzzing workflow, like how fuzzing looked like in past. So usually fuzzing would be a set of very tedious tasks that would be pursued by, let's say, members in a security team. They would first try to learn, they would spend a couple of days learning the build system and the underlying program APIs. And then they would start writing the fuzz targets in those. They would try to create these builds manually with different memory instrumentation tools like sanitizers. Then they will decide to run some of these fuzzers at scale, like either on their like local beefy machines or in the cloud. But a lot of these steps were very manual, like analysis of these crashes was very painful, and like the deduplication would be very rudimentary. So then they would file these crashes manually. And even after developer would fix these things, the verification was either manual or some of the folks might completely skip it. And the final part, even if the vulnerability gets fixed upstream in the OSS repo, consumers would find it pretty hard to uptake those fixes. And the reason being that OSS developers are very resource constrained. Like they might not even bother with like filing for the complicated CVE process. So in a way, taking those fixed vulnerabilities would be hard. So we have really worked on trying to simplify this fuzzing workflow. So first thing is we encourage the actual developers to integrate fuzzing in their projects. So that saves quite a bit of time. Like in usual cases, we have seen like a developer spending roughly a day to write like a fuzzer unit test and the related integration files. And this could be easily done in less than 100 lines of code. And rest of the workflow, we have tried to automate it completely. So to give you an example, for OSSFuzz, it will automatically create the right builds with all these memory instrumentation tools like sanitizers, and also hook into the available fuzzing engines. It will run these fuzz targets at massive scale. It will automatically analyze all these crashes, deduplicate them, and file them automatically. It will CC the developers in an automated fashion as well. And once a developer fixes those issues, they will actually verify the vulnerability as well. And in case, like if the developer didn't fix it properly, they will get a notification to fix it. So that's the automation from OSSFuzz. And then we recently announced a new service called OSV, which tries to make uptaking vulnerability fixes much easier. So we are encouraging the community towards capturing more precise vulnerability data, where you will exactly capture like the right regression and fix commits. And in that way, it can easily hook into your vulnerability management systems. So OSSFuzz has been serving the open source community for a while now, and we have some great results and impact to come out of it. So right now, more than 400 open source projects are integrated in the OSSFuzz service and are getting continuously fuzzed. So think of your popular critical open source library, like let's say curl, TensorFlow, Kubernetes, OpenSSL, etc., are all getting fuzzed through OSSFuzz. Till date, we have found 6,000 security vulnerabilities. These are all unique vulnerabilities we've found so far, and also like 22,000 functional bugs. last year, we also massively scaled our infrastructure. So now it's running on a scale of 100K CPU cores. So this is really helping the fuzzing for projects, because every project is guaranteed to get at least a few hundred cores. And we uncover most vulnerabilities pretty quickly. So they don't even make up to the stable branches at all. So now we will be going over our collaboration with Code Intelligence folks. So I would let Fabian take over and go over that.
Thank you, Abhishek. Yeah, now I'm taking over. And yeah, as you've heard from Abhishek, until very recently, Java was a notable omission in the list of languages that OSSFuzz supported. This has changed in, well, this early March, when the newly released JSON Fuzzer, produced by Code Intelligence and open source on GitHub below, which was only open sourced in February, so this is also a very recent addition, came out. And what is this fuzzer? It's based on proven tools like the libfuzzer fuzzing engine and Jacoco for coverage instrumentation. It's coverage guided, like all modern fuzzers are. It's in process, which means that in the same process that your fuzzer runs, your Java virtual machine will execute your Java target. So this is actually really fast. Like you get 1 million executions per second on an empty target, and still maybe 100,000 executions on a realistic target. And the good thing is that you instrument bytecode directly. So you don't need source code, and this will be directly compatible with your Kotlin Scala Clojure application. Yeah, so what makes JSON a good fuzzer? It takes all the tried and tested libfuzzer features and ports them to Java. So for example, you get automated minimization with deduplication, and this also works on ClusterFuzz. You can fuzz in parallel. You have a value profile that allows you to break complicated checks into smaller steps and make the fuzzer progress better. And it has also some additional Java smarts. For example, you get pure Java reproducers that you can share with maintainers. You have a keep going mode to skip very uninteresting null pointer exceptions in favor of the more interesting bugs. And you have an elaborate method hooking framework with which you can implement your own Java equivalents of the C++ sanitizers. So let's look into what JSON can do, or what a JSON fuzz target looks like. So this is an example fuzzer with two helper functions that perform things that you can, well, often see in apps or web apps that are sometimes a bit broken. For example, here you can see base 64 encoding, takes a byte array, turns it into a base 64 string, and a very, very insecure XOR-based encrypt function with a static key. And then further down, you have a fuzz target. A JSON fuzz target is just a static fuzzer test one input function that takes a fuzz data provider. That's a Java object that provides you convenience functions to create useful primitive Java types from the raw fuzzer input. And then it does some, well, basically magic compares. So it takes some bytes from the fuzzer input, converts them to base 64, and compares them to some magic value. And it does the same thing for the result of this insecure encrypt, and then compares them with very, well, large magic long values. And then in the end, if the fuzzer has passed all these checks, it will lead to an uncaught exception, which will be reported as a crash. And as it turns out, if you run JSON, it only takes about 5 seconds to crash this target. So this is how you would invoke JSON on this target. And you can see that after about 2.5 million runs, with over 600,000 runs per second, it has crashed the application. It has produced the illegal state exception. And you can see further down that the crashing input is JSON value profiling. So using this feature, you can actually get into even complicated fuzz targets pretty quickly. You can also see some of the additional features here, like Java reproducers and the dedup token for deduplication. So we have a capable fuzzer, but what do we do with it? You could say Java is safe. I mean, it is memory safe, and it's also pretty safe in other senses. So why should you fuzz Java? Well, first of all, even Java applications have functional bugs. You can have uncaught exceptions that crash your services or applications. You can have assertions in there that you thought would never, well, not hold, but in fact, sometimes that can happen. Or you can just have multiple implementations or libraries that cover the same use case, but still produce incorrect results, as in different results for the same input. But then there are also potential security issues. Easy to detect are infinite loops and out-of-memory errors, which could result in very efficient denial-of-service attacks. But then there's also cross-site scripting in the context of web applications, for example, in sanitizers that are Java-based or HTML frameworks, or even remote code execution. So for example, if you deserialize untrusted Java objects, or if you run Jakarta with an expression language, you can actually get remote code execution in the supportedly safe Java language. And all these can be found via fuzzing. So now that we've seen this, let's look into some real bugs that Jesser has found. So in this part, we'll look at the JSON Sanitizer, which is an OWASP but Java library that you can feed arbitrary bytes and strings into, and it guarantees that the output is always valid JSON. Even more than that, it guarantees that the output will never contain certain substrings that, due to the weird nature in which HTML is parsed, might mess up your scripts if you include the output of this thing verbatim into your script blocks. So you can take untrusted data, that's the claim, you can run it through the JSON Sanitizer, and the output should be safe to be embedded right in a script block in your HTML, like below in the orange box. Well, what did we do? We set this up with some kind of a property-based fuzzing approach in Jesser. So this is the fuzz target. We're just consuming a string. We're passing it through the sanitizer. We're catching any exceptions because that's not what we're interested in right here. We also found some undeclared ones. And then we're asserting that the safe JSON that comes out of this does not contain this substring. Because if it does, we could get cross-site scripting. And you can probably tell, I mean, I wouldn't be telling you this if we wouldn't have found a bug. So we found a bypass of the JSON Sanitizer. It's actually not that hard if you use JSON escaping in a smart way, namely you escape the first letter of an HTML tag in your JSON string. You can pass it through the sanitizer and it will output the original tag. So what you can do is that you can take the string up there, you can pass it through the sanitizer, it will end up in the HTML that I showed you before, but there, because of the nature of HTML, this closing script tag in a JavaScript string will actually close the script block. You start a new one, you insert an alert, and you get cross-site scripting. So this is an example of a high-severity security vulnerability in a Java project that you can find with fuzzing. And there are more. We can look at this code snippet, which is a utility function, IO utility function in a popular library. And it's supposed to read a buffer up to a certain length and consume it fully. And what does it do? Well, it initializes a buffer to read into, and then it starts a loop. And it calls a read method. We don't know what this is, but it calls a read method and tries to read as many bytes as it still needs to read length bytes in total. So what could possibly go wrong with this method? Well, what does the read method return if there is not any data anymore? It turns out that in this case, it didn't return an error or something like -1. It just returned 0. So that means that you call yourself up in an infinite loop if the buffer contains less than length many bytes. And this actually led to an infinite loop in Apache PDF box on a stable branch, got a CVE assigned. And this is a bug that, for example, you could abuse in the context of a web application that accepts some PDF, for example, to parse out some text from it. With just a 500-byte PDF, you could consume many resources on that server and potentially crash it or just denial of service completely with very little effort. And there's the fuzz target that uncovered this bug. It's very simple. As Abhishek said, these fuzz targets are usually pretty short. So here, it's just, I think 6 lines of code. You just load a PDF from the raw input data of that the fuzzer provided you with. You set a memory limit. you catch the exceptions that this thing declares, and then you let it run. And it will find this bug pretty quickly. But you could say, okay, this is not very interesting. I mean, the fuzzer, every fuzzer should find bugs where some size, some length is not as claimed. But Jesser can do more. So we also found an infinite loop in Apache Commons Compress. This has no CVE because this was on a branch which was close to being released, but luckily hadn't been released yet. Here, the fuzz target is even shorter. And what went wrong? Well, in Apache Commons Compress, a tar file allowed negative sizes for files to be claimed in the file metadata. But then Jesser pretty quickly produced a tar file with a file entry whose metadata claimed that the file had a size of minus the length of the metadata, which was 512 bytes. So that meant that after Apache Commons Compress had parsed the metadata, it would set out to parse the file contents, which meant going back right to the start of the metadata. So it would now encounter, on the next loop through the parser, it would encounter a new file entry. It would parse it again, go back, and so on ad infinitum. And that, well, gives you the lovely sight of a Java out-of-memory error caused by an infinite loop. This was also a 500-byte tar file that's easy to produce, easy to upload, will be accepted anywhere, and can potentially crash your server, or even worse. So these were just 3 examples of the things we found with Jesser by ourselves or on OSSFuzz. And in total, since Jesser's release in mid-February this year, we found over 50 bugs in over 15 open source projects that we've fuzzed, and we haven't really fuzzed all the projects that we can think of yet. In those, we found 8 security issues, 5 of which have been part of stable or other released versions of software. So these have been assigned CVEs. All have been fixed. And yeah, we've also gotten quite a bit of positive feedback, for example, by the developer of the JSON parser library, Cowtown Coder, Tatu. And yeah, as you can see in the middle, this is up and running on OSSFuzz and can also distinguish between ordinary bugs and security issues. So yeah, we would like to ask all of you to, if you maintain a library or just know of a library, to bring this onto OSSFuzz, to let it be fuzzed with Jesser. Thank you.
Okay, thank you both so much for your talk. And I apologize, I only just realized I didn't introduce you properly. I just gave your names, not your bio. So sorry for that. I don't know where my head was then. Okay, we've been getting some questions in. But first, let me say that I think OSSFuzz is one of the most exciting security projects out there. I think the reach of OSSFuzz is fantastic and is a really important step forward for the community. Okay, so Net Zero is asking, how do you handle communication? How do you incentivize projects to remediate things? So not only how do you motivate them to join in the first place, but how do you keep things running once bugs start being found?
So most of it, I would say, is all automatic. Like there is no manual communication at all. They only sign up in like this project.yaml file where they declare like the set of people that want to get CC'd on these new bug reports. And as new bugs are found by OSSFuzz, it automatically CCs them and automatically tells them when bugs are verified. So there is no manual interaction involved at all, other than just merging in the first PR from them, which is kind of an integration PR. We encourage them to keep their fuzzers inside their repo so they don't have to ask us for reviews. So most of the glue code is in their repository itself.
Okay, and a follow-up question also from Net Zero is, how do you actually do the scheduling for all the projects? So is it kind of after major commits or after a certain number of commits? How do you decide when to schedule which project?
So given that we have limited resources, we create the builds once a day. We recently started supporting like doing builds a day as well for critical projects, but eventually we will try to see if we can scale it even more. Like do every commit. That might be feasible at some point, but given that we want to scale to thousands of projects, that might be hard. But still, we catch regressions within a few hours, so that's still pretty quick, I would say.
Okay. I have a question for Fabian. Regarding Jazza, could you please share your thoughts on the difference between it and JQF, a property-based fuzzer for Java?
Right. So JQF was certainly a motivation in building Jazza, and you can sort of find some of the ideas that it pioneered, like this structured or semantic or property-based testing fuzzing in the fuzz data provider. So you have something very similar in JQF, where you get a lot of Java primitive types right off your fuzzer input without much work: strings, arrays, Boolean, random choices. All this is available in Jazza. I'd say that Jazza has sort of a more modern backend. It builds on the proven libfuzzer. It has a very good coverage instrumentation, which is Jacoco plus a few extra smarts that work very well in fuzzing. It has hooking. It has a feedback loop to the fuzzer that informs the fuzzer about string compares, magic values, all these things. So I think, yeah, it's more efficient, it's faster, but yeah, it owes to its predecessors.
Okay. And another question along that line is, how was your experience integrating Jazza into a project as large and well, as large as OSSFuzz?
Oh, this was, I mean, apart from a very few edge case bugs, which all had to do with native libraries, which are always a bit of a complicated story in the Java world, all of this went very smoothly. So as Abhishek has said, if it works locally, it works in the cloud, and that mostly held up true. Because, I mean, the good thing about OSSFuzz is that it doesn't have any assumptions on what fuzzers do or what they look like. You have Docker files, and you have sort of very generic ways of interacting with the fuzzers that generalize to Jazza rightly. And yeah, I think we actually benefited from basically being libfuzzer plus Java smarts, which meant that we are fully compatible with libfuzzer CLI commands, and that meant that the whole process was pretty smooth.
Awesome. So Abhishek, after having integrated Jazza, what other kind of fuzzers would you like to see the community create and integrate into OSSFuzz?
I would definitely say we are really looking for more fuzzing research. So we would want first more fuzzing engines to be tested inside FuzzBench. So things like more symbolic execution engines like SimCC would be very ideal to have it in FuzzBench, and then getting into OSSFuzz. And we encourage the community to develop more engines. Like, we don't want to just stick to, let's say, AFL++, libfuzzer, and HongFuzz. We definitely want more fuzzing engines there.
So is there any language in particular you'd like to see more work on?
I would say definitely more work on the memory safe stuff. So like very excited about the Java fuzzing work that Code Intelligence folks did. Because sometimes we always have that convention around like, hey, we cannot find interesting bugs in memory safe language. And that's not true. Like, to give you an example, OSSFuzz found a bug in Golang which could actually crash down most of the Ethereum network. So that's pretty serious. So we want to change that notion where people just think, hey, it's not worth it to fuzz memory safe languages. So we definitely encourage more research there.
Okay, awesome. Okay, then I have one self-declared newbie question for you both. Can we do API fuzzing using OSSFuzz?
I think so, yeah. At some point, we would be looking into it. It's more, do you mean web APIs, or what do you mean? Like,
I'm not quite sure what Taj meant. If you're listening, Taj, and can type quickly, I see keyboards are being
this conference.
Because we call it like API fuzzing. It's like unit test running the program API, but I think maybe he means web apps.
Yes, I'm guessing. I'll also guess that it's web application APIs.
Well, I think
we're not
we
hearing
have
back
there that Microsoft research folks pointed out, so that's great. And I think, Fabian, you guys have a web API fuzzing solution too, right? So that would be very nice to integrate in OSSFuzz at some point.
So yeah, that will come up next.
Okay, then looking at time, thank you both for the interesting talk.
Thank you very much.